Hello, this is Nikki Jackson, one of the adjunct instructors for Concord Career College. As you can see on the screen, this is an example of a rational expression written as a factor, or written as a fraction, my apologies. But before I get into the explanation, these are examples taken from homework assignment 6. So going back to the actual fraction, to solve for this, you want to simplify by eliminating common factors. So pay close attention that both the top and the bottom have a y, and you have to think about your multiplication. What number could go into both 24 and 54 at the same time? So I did this earlier, so it'll be easier to record. Well, 6 can go into both 24 and 54 evenly. Notice how I crossed out the y's, so your only variable remaining is an x on top. 24 divided by 6 gave you the 4. And then 54 divided by 6 gives you 9. Your overall answer is 4x over 9. Next, we have yet another one, rational expression in regards to factoring and simplifying. So given to you, you have x squared minus 81 over x squared plus 9x. So simplify by factoring. So what I did for the numerator, we made this and factored it out into the difference between two binomials. So we have split it. We got x here and x there. We know that the square root of 81 is 9. So 9 here, 9 there. Because there is no middle term up here, it is assumed that one is going to be a plus, the one is going to be a minus. Then let's take a look at the denominator. Notice how both there are x's in the first term and the second term. So we're going to factor x out. Once we factor it, we're left with x plus 9. Now, let's look for even more common terms, where there's an x plus 9 in your numerator and an x plus 9 in the denominator. Notice how these are marked out. So now you're left with x minus 9 over x as your final answer. Be mindful that rational expressions can be simplified to make them even smaller, but it takes some time to actually look at it. So here goes yet another one. This is example number 3. Once again, you have it as a fraction. So you have 27x to the 4th power plus 64x over 12x cubed minus 32x squared minus 64. So that's just a lot all by itself. So we're going to simplify it by looking for the common factors. So take a moment to see what can go into 27 and 64. Then, what can go into 12, negative 32, and 64 in the denominator. Well, let's look at only the numerator. So for the numerator, I factored out the x. So now I'm left with 27x cubed plus 64. Notice the format. It is in the form of a sum of cubes. So the sum of cubes formula is a cubed plus b cubed equals a times b, or a plus b, times a squared minus ab plus b squared. And if we look at this carefully, we see that we have the x cubed, so we already know it's going to have an x in it. And we also know that 3 times 3 times 3 gives you 27. So that makes a your 3x. Then we're looking at 64. Think long and hard about this. What can you multiply to itself 3 times to give you 64? That would be 4. So I'm going to move on. But before I do that, look at your denominator. Notice how I factor out an x here as well. So took the x out. You're now left with 12x squared minus 36x minus 64. Notice how these x's, once they're factored, cancel each other out. So I substituted my a and my b into my formula. So this is what I have resolved. This might be the ideal time for you to actually pause the video and to rewind it and see what happened. Otherwise, we're going to look at the denominator. Notice how there's a 4 on the outside. So I factored out 4 to make the 12, the 32, and 64 even smaller. So now we're left with that. Using the AC method, for your denominator only, we have to think about what can we get when we multiply 3 and 16. So let's think about that. Using the AC method, if you multiply 3 and 16, you're going to get that 48. But you're looking for a middle term of 8. So let's zoom in for a moment. So I did a rough sketch of this. Yes, it is rough. Yes, it is. Ow. So 3 times 16 gave you the 48. And we want that middle term to be 8. So right listed on the left, I gave you all the factors of 48. Listed on the right, those are the sums and differences. Now we want it to be a sum, but remember, you can also add negative numbers too. So that just made it a little bit easier for the subtraction. So notice how when I wrote them all down, when you add and subtract, they have to give you the 8 for your middle term. So I stopped right here because 4 plus 12 gives you 16, but 12 minus 4 gives you 8. And if you multiply the two, that gives you the 48. So now let's see what we did for that part. So we factored using the AC method, and now we're going to group it. Well, remember, we already did our numerator. So now with our denominator, notice how I split it by grouping. Now we're going to factor out even more. So again, the numerator stayed the same. I brought that 4 down, and I brought the 3 out. So 3 and x is a factor for both of these, so there it goes. You're left with x minus 4. Looking at these two, you can factor out a 4, so that's what it is. But notice how you got an x minus 4 right here, and an x minus 4 right here. Notice what's on the outside. 3x plus 4. So with your numerator, you have 3x plus 4 times 9x minus 12x plus 16. For your denominator, your 4 is still on the outside, but once we simplified it, we got 3x plus 4 times x minus 4. Remember this part right here? Well, look, we have a 3x plus 4 both on the top and the bottom. So we can eliminate those. So now as your final answer, you have 9x squared minus 12x plus 16 over 4 times x minus 4. Now as we continue to make progress, rational expressions either going to get a little bit harder or a little bit easier. So let's look at this one. This was what I would call one with a little bit more ease. We're going to simplify that. Now notice how you're going to multiply as well because we got two fractions going on. So for the first one, you have 9xy over 10y squared times 18x to the 5th power y over 27. So woohoo, haha, yay. Rewrote the second one, 18x to the 5th power y over 27. Now, I tried to simplify it on the front end because I noticed diagonally I got a 9 and 27. Well, 9 can go into itself one time, and 9 can go into 27 3. So you may notice the 1 here and the 3 here. Then I look diagonally with the 10 and the 18. Both of those are even numbers. So 10 can be divided by 2 5 times, and 19 can be divided by 10 can be divided by 2 5 times, and 18 can be divided by 2 9 times. So my apologies, you guys. I'm thinking and talking are not at the same pace right now. So 1 times 9 gives you the 8, 6, and the y squared. But hold up, wait a minute. Your exponents are different. You may remember when we were doing homework 4 and 5, when you're multiplying your variables, you're going to add their exponents. So 1x plus 5x gives you the 6x. 1y plus 1y gives you the 2y's. Now let's look at the denominator. 5 times 3 gives you 15. You just have your y2 right here, and we bring it over. Next step, we still got to simplify. Well, 3 can go into both 9 and 15. So 9 divided by 3 is 3. 15 divided by 3 is 5. Let's look at these exponents now. There are no x's on the denominator, so you're just going to bring this x 6 down. But check this out. The y's cancel out, so they are going bye-bye with your overall answer of 3x to the 6th power over 5. Your next one is very similar, so let me take a moment to arrange my screen so you can see everything. Okay, so enough with the awkward silence. Here we go. This time around, instead of multiplying, we're going to divide. Well, notice how both of them are written as fractions. You cannot divide a fraction, but we can do something called the reciprocal. Now, what I would like to call is KFC. No, I'm not talking about the chicken, but I'm talking about keep your first fraction, which you see right here, flip your second fraction, and then change your division to multiplication. So what I mean by flip is the same as a reciprocal. Now we're going to multiply across. 5 times 5 is 25. Add your exponent, so you got 6 and 1 here, so that gives you the 7. Bring over your y. 18 times 7 is 126. Let's bring over your x squared and your y cubed. Now we're going to try to simplify where there is no common factor outside of 1 between 25 and 126, so that stays the same. But look at your x's and your y's. Well, if we were to subtract this, 7 minus 2 gives you 5. Notice how the 7 is the bigger one, so it stays on top, so the x to the 5th is on top. Look at your y's now. 3 is bigger on the bottom, so 3 minus 1 gives you 2. Remember what I just said about the 3's on the bottom? Hence your 2 is on the bottom. This is going back to with your exponents when you want to write them with positive exponents. Here's another one pertaining to multiplication. But one of the things that I did right here was try to simplify it first. So I factored out right here because 5 can go into 10 2 times. So factor out the 5. Hence you have 5 times x plus 2. Can't factor this one out. You really want to, but you can't. Because notice how there's a plus sign right here. That can only be factorable if that was a minus. So this is not factorable. And for your denominator, you're just going to multiply the xy. But look at this one. This one can be factored. So let's think about what can give you 16. You have 1 and 16, 8 and 2, and then you have 4 and 4. Well, I did the 8 and 2 because just so happens 8 plus 2 also gives you 10. They're both positives because there's a plus on each term. So that's where we factor this out. But check it out. The x plus 2's factor out. So now you're left with your overall answer of 5 times x plus 4 over 8y plus x plus 8. And there is more, yeah. Now you remember the example from earlier when we were pertaining to the multiplication? For multiplication, you're going to add your exponents. With division, you're going to subtract. We also have to make sure that we do the reciprocal of the second one, the KFC. So keep your first one, flip your second one, and change your division to multiplication. So look diagonally. 15 and 20 are both factors of 5, or multiples of 5. So 15 divided by 5 gives you 3. 20 divided by 5 gives you 4. So that's where the 4 and the 3 are in the bottom. Then the next, I'm going to factor this one. Notice how both your x squared and your 7x both have x. So if I factor out an x, I'm left with x times x plus 7. Brought down my 3y squared. In regards to your denominators, bring down your 4y right here. But now I have x squared plus 14x plus 49. Well, let's look at that 49. What can give you 49? Well, you know you have 1 times 49, and then you have 7 times 7. Well, when you factor it out, notice how you got your two x's. So you have an x here, and you have an x here. We just agreed that it was going to be 7. So a 7 here and a 7 there. Both of them are positive, so they're both plus 7. Well, once again, we can factor. So this is crossing out, this is crossing out, because those are canceled. We have 2 y's up here for 1 y right here. So 2 minus 1 gives you that 1. Bring it down. We have 3x, bring down that y. And then we have 4 times x plus 7. For this one, it's still a rational expression, and you're subtracting. Now, we have to make sure that we have a least common denominator for this. So what I call this is called the butterfly method. So notice how both of your denominators are 6x and 10x. So 6 times 10 gives you 60, and you have your 2 x's, hence the x squared. Diagonally, 5 times 10x gives you the 50x, and then 3 times 6x gives you the 18x. Notice how I just put the minus sign in the middle. 50 minus 18 now is 32, but now 32x, I'm sorry. But now you can simplify. You have an x on the top and 2 x's right here. Remember, you can subtract your x's. So 2 minus 1 gives you the 1x. 32 and 60 are both multiples of 4, so 32 divided by 4 gives you the 8, and the 60 divided by 4 is 15. Hence, your overall answer is going to be 8 over 15x. So pay close attention to this part right here with your x's. I'm subtracting. Still pertaining to rational numbers. With this one, we're still going to add. And just like subtraction, we have to find the least common denominator. So I multiply using the butterfly method. So I went across. So x minus 1 times x. That's why you have that down here at the bottom. Then for your top part, I cross multiply. So 3x times x gives you the 3x squared. And then bring over your plus sign. And then 4 times x. That gives you the 4x, and 4 times minus 1 gives you the negative 4. And that's it. You can't simplify anything further. That is your overall answer. Now, number 10 is a doozy. So take a moment to just inhale, exhale, find the center in the back of your mind. So once again, we're going to use the butterfly method. So we're going to multiply across for our denominator. So that's 2x plus 1 times 3x plus 4. So that's where we got that from. Now we're going to cross multiply diagonally. So we have 2 times 3x plus 4. Bring over your plus sign. And then multiply, oops, that's a little bit too big. 1 times 2x plus 1. That's where we got that from. Alright, so using the distributive property. Now, in order to do the distributive property, that's the same thing as multiplication. So what we want to do is multiply whatever we see on the inside by whatever we see on the outside. So 2 times 3x gives you 6x, and 2 times 4 gives you the 8. Bring down your 2x plus 1. Now let's combine like terms. We got 6x and a 2x. That gives you 8x. Then we have an 8 plus 1. That gives you 9. Notice how the denominator did not change. So this is your final answer. And then we have even one that's more complicated. Woohoo! Once again, we're going to do the butterfly method. And that might even not be the proper term. That's just the way that I say it. Because you can put little squiggly marks on it. Watch. My handwriting kind of sucks right now. But I can do this, and then this, and put a little dot here, and then put a little dot there, and voila! It's breaking out of this cocoon. Okay, so jokes aside, so once we do this, we're going to cross multiply, and then we're going to do the diagonal. So pay attention very carefully to what I just did with that one. So look at your numerator and then look at your denominator. So with your numerator, we have 2x squared plus 5x plus 20x. Your denominator stays the same. We're going to combine like terms. So 2 plus 5 gives you the 7x squared. Bring down the plus 20x. But notice how you can now eliminate some of the x's. So with the 7x squared, we now have a 1x. And then with the 20x, we just have the x. So if you simplify, this is what you have. But right here, we can still factor out an x. So it wants it in simplest form. So now your final answer is 7x plus 20 over x plus 4. So you factor out that x right there. Now here are one of the more longer problems. So let's take a moment to just look at it. Because remember, you always have to find your least common denominator. So here we go right here. We know that we're going to multiply the bottom part. So these two bottoms are going to stay as bottoms. Then we're going to do the diagonal part for one of them. And then we're going to do the diagonal part for the other. So this is what I did right here for the diagonal parts. So yeah, that was a lot of numbers. Your next step now is going to be the distributive property. So whatever's on the outside multiplied by on the inside. So we have the 5a times the 4a squared, so that's 20a cubed. The 5a times the 13a, so that's 65a squared. Then the 5a times 12, so that's going to be the 60a. Bring down the 8a squared minus 2a minus 3. Now we're going to combine like terms. Well, I know that I can do something with the 65a squared and the 8a squared. I also can combine the 60a and the minus 2a. So, watch this. I made a mistake, so my apologies. Okay, so ignore the scribble. I brought down the 20a cubed, hence here it is right here. I crossed it out. I combined my 65a squared and my 8a squared, hence the 73a squared, crossed it out. I combined my negative 6a minus my 2a, so that's negative 62a, crossed it out, and then I was left with the 3, brought it down. All of that is still over 8x squared minus 2a minus 3 plus 13a minus 2. So all of that is still over that. So this part is your numerator. This part is your denominator. So here goes your numerator only, because I don't want to do anything else with it. But the trick part is the denominator. Now that denominator was a lot, like a lot. So here we go right here. So let me break it down as simple as I possibly can. Hopefully, maybe, perhaps, maybe. Fingers crossed. Okay. So now we got 8x squared minus 2a minus 3. And then the other one we have 4x squared plus 13a minus 12. This is a line right here. I'm going to divide them. So I'm splitting them so we can work them side by side. Using the AC method, 8 times 3 gives you 24. So we're looking for something that if we multiply it together, it gives you 24, but if you add or subtract it, it gives you 2. That's this 2 part right here. So I did that for you. So let me zoom my way in. So here are your factors of 24. And we're looking for something that will give you 2. Well, the only one that can actually give you 2 if you add or subtract it would be 4 and 6. So now I'm going to go back to my denominator. Here goes your 4 and your 6. Now pay close attention to the signs. We're trying to group it. So we know 6 is a factor of 3 or a multiple of 3, and 4 is a factor of 8. So that's why we split them up like that. Pay attention to your signs because 6 is bigger, hence that's why it's the minus. And you have to get that 2. So right here, I factored out a 4a. That's 4a right there. It's kind of scribbled. So 4a can go into 8x squared 2a times. And then bring down your 1. So this right here is 4 times 2a. Bring down your minus sign. You can factor out a 3 for both of these. So when you factor out 3, you're still left with 2a. Notice how you got a 2a plus 1 here and a 2a plus 1 here. Look on the outside now. You got a 4a and a minus 3. So here's the factor for that part. The second part of the denominator, still using the AC method. So a is 4, c is negative 12. 4 times 12 gives you 48. What numbers can give you 48 if you multiply them, but if you add or subtract them, you can give you 13. So let's figure that out. So here we go. I wrote it out for you already. So I wrote all of them. I literally wrote all of them. And I'm still trying to get that 13. So I'm looking at them because this would be 49, 47. This would be 26 and 22. This would be 13 or 19. This will be either 8 or 16. And this would either be 2 or 14. We want 13. So here we go. So looking at that denominator, and when I split it, so here's my grouping right here. I have the 16 and the 3. We have to carefully put them in order according to the signs. Since the 13 is positive, we know out of these two numbers it's going to go with the bigger number because it's plus. So using grouping, I can get this taken out, which is also known as factoring. So 4a times a plus 4. And then right here, I can factor out a 3. I still got a plus 4. So we know that the a plus 4 has to be part of your factoring, which is that part right there. And then we're going to combine this right here. So now that part of your denominator, you have 4a minus 3 times a plus 4. Now remember, that was just the denominator. There's a lot more to go. Now we're going to combine it. So here's your numerator and your denominator together. So we can see that we can actually factor out I didn't show you how to factor that out, did I? No. I left you hanging with it. I surely did. I have misplaced a sheet, ladies, gents, individuals. So if you're actually enrolled in my course, make sure you shoot me an email because I stopped. And I don't remember who I did. But I know they'll cancel and that cancels. So it looks like you're going to be left with 7 times a plus 3 over 2a plus 1. 4a minus 3 times a plus 4. The denominator, I know I just showed you how to do that. But I misplaced the numerator. That's my fault. 100% all the way. So you're going to get that problem partially correct. Yeah, you are. So my apologies. Now I have to move on to number 13. Because time and money are two things I cannot give you. Okay, so here goes 13. Take a moment to look at that very, 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 very carefully. So once again, you know you're going to do the so-called butterfly method. So keep your denominators as they are. So you know, this is what we're going to do. So ta-da. Now here's what you may not know. You know you're going to do the diagonal part right here. So that's where this came from. And you know you're going to do the diagonal part right here. So that's where that came from. Here is your denominator. You just multiplied until, and you didn't even actually do the full multiplication. You just put them together. But here where it gets a little bit more complicated. Using distributive property and combining like terms. Alright, so let's look at the numerator first. So we have 9x squared times x. They gave you the 9x squared. Bring down your minus sign, and now we got 27x. Right here, using the distributive property. Did it twice, but hopefully you got whatever it meant. Now we have the negative x squared. Two negatives give you positive, so that's plus 48x. And then a negative times a positive gives you a negative, so that's where the negative 72. Combining your like terms, so we got 9 minus 8 gives you that 1x squared, so they are crossed out because we use them. Then we got negative 27 plus 48, so that's going to give you positive 21x, so they're crossed out because we use them. And we don't have anything to combine with the negative 72, so we brought it over. Now here's where it gets slightly confusing. This one right here, we rewrote and brought it down right there. There it is. But look at this part. We can factor this. We know that 9 is a perfect square. So 9 times 9, the square root of 9 is 3. And then that's the 3 right here. That's the 3 right here. We also know that it's going to be both negatives because two negatives give you a positive, but you have a minus 6 right here. So you just factor out this part right here. So that's why you see the 3x minus 3s. But there's still more to go. I can factor them out now. When you factor them out, did I miss a page? My apologies for my awkward silence. Oh, I didn't tell you that part. So that's where I messed up there. So let me go back, let me go back, let me go back, let me go back, let me go back. There we go. Alright, so this part, you understood what I did when I did combine like terms. You also should have understood where I got the 3x minus 3s. What I didn't do right here, or I showed you, we're still going to factor this one. So look at your end term. Your end term is negative 72. End, E-N-D term, not end term. So what can we do to multiply to get 72? But somehow or another, if we add or subtract, it's going to give you the 21. So here we go. This is what I did. I broke all the factors down. Broke it down. Wrote it down and broke it down. So 1 and 72, 2 and 36, 3 and 24, 4 and 18, 12 and 6 and 8 and 9. Remember, we want 21. Well, we can't use 8 and 9 because that's either going to give you 1 or 17 if you add or subtract it. Can't do 12 and 6 because if you add or subtract that, it's either going to give you 18 or 6. Can't do 4 and 18 because that's either going to give you 14 or 21. No, 22. I can't add, y'all. 22. But if I do 3 and 24, that will give you 21. Hence, that's why I have that dot there. So let me zoom out. So here's where we factor. So we were using the 3 and the 24 right here. Right there, we know there's going to be a positive 24 because if you go back and rewind a little bit, you see that we have a 21x as our middle term. But also notice, we can eliminate the x minus 3's. So bring over the x plus 24. And how many x minus 3 do you see now? You see 2, hence it's to the second power. So yeah, 2. Still pertaining to rational numbers. So let me get the pencil out the way and then zoom all the way in. Okay. So this looks kind of confusing. You have one fraction right here divided by another fraction down here. Do you remember the KFC I was talking about? And no, I'm not talking about Kentucky Fried Chicken, even though it is lunchtime right now. What I mean is I'm going to keep my first fraction, which is 5 over 6y, flip my second fraction. So if you notice what I did right here, so now I got 10 over 3xy, and change my division to multiplication. So that's what I'm doing right here. Once I've done that, I can simplify everything. So 5 times 3 gives you the 15. Bring over your x, bring over your y. 6 times 10 gives you 60 to bring over your y. But you can still simplify it even further. 15 and 60 can be reduced because 15 can go into itself one time. And then 60 divided by 15 is 4. Notice how I canceled out my y's right here, because that's a y and that's a y, so they're gone. So you're just left with 1x over 4. Because remember, when you do this part right here, that was 1. Because you're dividing both things by 15 if you see that part right there. So x over 4 is your final answer. So yeehaw! But there's even more to come. Okay. So once again, we have fractions within fractions. But now, not only do we have to do that, we also have to find least common denominators because you're adding and you're subtracting. So you got a lot going on right now. So the first thing we're going to do is look at your numerator only. So on my top part, I see 3 plus 1 over n plus 8. I made that whole number a fraction too to make it a little bit easier. So I'm using the butterfly method. So 1 times n plus 8 gives you n plus 8. Then diagonally, 3 times n gives you 3n. 3 times 8 gives you 24. And then 1 times 1 gives you 1. Combine your like terms, you now have 3n plus 25 over n plus 8. That was just the numerator. Now let's look at the denominator. So we have 5 minus 2 over n plus 8. Make that 5 a fraction as well by putting it over 1. So your denominator is n plus 8. Using your diagonal to multiply, we got 5n plus 40, and then 2 times 1 gives you 2. It's a minus because that's a minus right there. Combine your like terms now, so now you have 5n plus 38 over n plus 8. So you got your numerator and your denominator now. But we're still not done. Remember, it's a fraction within a fraction. So now that we have that, remember the KFC, the keep, flip, change. So I'm rewriting it so I'm making it a little bit more easier to understand because here's your numerator divided by your denominator. Now we're going to do the keep, flip, change. Keep your first fraction, flip your second fraction. Well, notice what can be canceled out now. These are gone. So now your overall answer is 3n plus 25 over 5n plus 38. So this most definitely will be a problem that you might want to go back and review. And when you actually log in and complete it, try to do several examples. Next, we still have one pertaining to, it looks like division, in my opinion. So we're going to simplify all of this. Notice once again, you're going to subtract your exponents. So your final answer is going to be 4x to the 5th power plus 8x4. My apologies for the rushing, but I'm looking at the capacity of my video, so it may not necessarily take up that much memory. So my apologies. Alright, your next one. Once again, you have division. So I rewrote it as a fraction. Then I came back and I looked at this part. Now you're going to have to do a little cheating, and what I call cheating is not really cheating. But think about the factors of 150 that can give you 19. So I was using my calculator quite a bit, and I was thinking, and I know whatever it had to be a factor of 5. So the bigger I got, the more it got complex. So I started with 15 first. But 15, whatever factor of 15 that gave you 150 was too big to give you 19. So I thought of a bigger number. Thought of 20, still didn't give me 19. Then I thought of 25. What 25 could go into 150 6 times. And just so happens 25 minus 6 gives you 19. So again, this is where I'm factoring this out. So you split your x's. So here goes one x, here goes another x. By using your calculator, you did the 150, so that was 25, and then you did your 6. Notice how the 19 is positive, so it goes with your greater number. And because you've written it as a fraction, notice how the x minus 6's cancel each other out. Here's one that's even more complex in regards to division. This is what we call synthetic division. Now what I mean by synthetic division is long division. And yes, it's going to take a long time to do it as well. If by chance you're using MathWay, you got to be very careful when you do it because it may not necessarily give you the full answers. So for this particular problem, you're dividing 2x cubed minus x minus 2 by x plus 2. Well, I had to rewrite it because I wanted to make sure I had every term represented. So I got something to the 3rd power, something to the 2nd power, something to the 1st power, something to the 0 power. This is not given to you because it's just not. It's not existing. But when you do long division, make sure you represent it with 0. So here comes the long division part. We know that x plus 2 has to go into 2x cubed. Well, notice the coefficient of 2. So we're going to multiply everything by 2. In fact, multiply everything by 2x squared because that's just 1x. So when we multiply everything by 2x squared, you're getting 2x squared plus 4x squared because it's just these two terms. When you're subtracting though, all the signs change. So that's why I'm scribbling everywhere right here. So these cancel out, and then that brings it down to a negative 4x. Bring down that part right here, that x. Once again, we're going to multiply. So notice how we got negative 4x squared. Well, we know we got to have another x in it because that's just 1x. We also know we got to have a coefficient of 4. So we know it's going to be a negative 4 up here because we know two negatives give you what? Positive. So when you multiply it out, you got 4x squared minus 8x. And notice how I did not put my squares or my x's right there. So that's my fault. So now that you got 4x squared minus 8x, remember, you're going to subtract it. So daddy, mama, sister, brother. Daddy divide, mama for multiply, brother, so sister for subtract, and brother for bring down. Okay, so these cancel out. That minus is going to make that a plus. So now you got negative 7 plus 8x. That's the 7. We want to subtract this again, so now we're going to do times. So this has to be a 7. Multiply it out, so you got 7x plus 14. Remember, you're subtracting, so all your signs change. So now these cancel out, but now you got negative 14 right here and negative 2 that I did not bring down. When you combine those, because both of them are negatives now, you got negative 16. But look, you don't have anything else to bring down. You're done. And because of that, that's called your remainder. Hence, your overall answer is going to be 2x squared minus 4x plus 7 minus 16 over x plus 2. Now, where did the x plus 2 come from? Remember, that's what you're actually dividing by. So it's going to take several moments to actually understand this one. Your next one is also division. What I did was trying to find the least common denominator. So your denominators are 4, 6, and 3. And we also have x in the bottom parts too. So think about the smallest number that both 4, 6, and 3 all can go into. It's not 2, it's not 3. Think about a bigger number. It's 12. So multiply everything by 12x. 4 can go into 12 3 times. The x's cancel out. So 3 times 3 gives you 9. 6 can go into 12 2 times. But 2 times 5 gives you 10. Bring down your x. Bring down your equal sign. 3 can go into 12 4 times. 4 times 4 gives you 16. Notice how the x's cancel out. Now using general algebraic skills to isolate the variable of x, your final answer is 7 over 10. Here goes number 20. It's very similar to what we do for cross multiplication or solving proportions. So you're going to multiply each one diagonally. Once you do that, make sure you know how to add and subtract them. And yes, your final answer can be a fraction. So again, my apologies for not explaining it thoroughly, but I'm looking at the time and the memory because I have to upload this for you guys. Now I'm going to have to do some hit and miss on a couple of problems. What's going to wind up happening is that these are going to be the ones that we're going to actually do in virtual class because I'm looking at the time. And I do not like wasting more time because that's just not fair. Not fair at all. So, yeah. This is what we're going to have to do. I'm going to have to set it aside and end this video for right now. So we're still left with 21 through 25, I believe. So I'm going to have to do that at a later date. So ladies, gents, individuals, thank you so much. So when it's time for us to do Module 6, don't forget to ask those questions.